So today we're going to talk about prime factorization. And prime factorization is when you break down a number into the longest multiplication problem you can have that doesn't involve the number 1. It's a fancy way of saying something I'm going to explain now quickly. So we have these different types of numbers called primes and composites. Prime numbers are these numbers that look like this. They're listed here. And the only way of making a prime number is to multiply itself times the number 1. So the only way of making 2 is just 2 times 1. We're going to count that as the same as 1 times 2. So there's only one multiplication pair for each of the prime numbers. Only one way of making 11, and that's 11 times 1 as a multiplication problem. Only one way of making 17, 17 times 1. So that's about half of the numbers. And then we have these other numbers called composite numbers. And they're the partners of those. And instead, composite numbers are numbers that have more than one multiplication pair. So if we look at 4, 4 is 1 times 4, sure, but it's also 2 times 2. So that means 4 is not prime because there's two different ways of doing it. If I go down to 12 here, 12 is going to be 1 times 12, sure. It's also going to be 3 times 4. It's also going to be 2 times 6. So there's three sets of multiplication pairs. And really with primes there's only one. With composites there's at least 2. There could be many more than 2. But the idea is you've got to go ahead and recognize what's prime and what's composite first. Now these ones here, these prime numbers in particular, right up until 11, are going to be really important. So pay attention to those, and I'm going to write them on the slides ahead just so you can recognize that those are prime numbers. That's a good idea to do. So now let's talk about this idea of how to break down these numbers. So when I break down a number that's a composite number, and remember a composite number is a number that can be broken down into a second multiplication pair. I'm going to break this number down, 15, into something other than 1 times 15. So one way I can do that is 5 times 3. That's really the only way of doing it because 15 only has those two multiplication pairs, 5 times 3 and 1 times 15. So I'm going to look over here. Let's see. Are 5 and 3 prime? Yes, they are. So that means I'm done because this times this is equal to that. So the prime factorization of 15 is equal to 3 times 5 because I've broken it down into a multiplication problem with just prime numbers. So let's try that again. Let's try it with 33. So 33, I could do 1 times 33, but I need to get this down into prime numbers. So the way I'm going to do that is 3 times 11. And this, again, only has one other multiplication pair. So this is prime if I check up there on the right. This is prime. So 33 is equal to 3 times 11. That's all prime factorization is. So 3 times 5 and 3 times 11 is the prime factorization of those numbers. So now we're going to do a couple more quickly. So 20, how do I break down 20 into a multiplication problem that doesn't involve 1? Well, I can break it down in a few different ways, but I'm just going to choose 2 times 10. Now the next step is either of those numbers prime? Well, yeah, 2 is, so I circle that and stop there on that part. Is 10 prime? No, it's not, because I can still make another multiplication problem out of it. So this is going to be 2 times 5. It's going to be 2 and 5. And both those are on that list. So 20 prime factorized is going to be equal to 2 times 2 times 5. 70 prime factorized is going to be, well, I could do it a lot of different ways, but choose the one that's easiest. For me, that's 7 times 10. And 7 is prime. And then this is going to break down into 5 times 2. So 70 prime factorized is going to be equal to 2 times 5 times 7. Now, one of the beauties of prime factorization is if you get the math right, then no matter what path you take, you're going to end up with the same prime factorization. What I mean by that is this. If I have 30, I'm going to do 30 two different ways. 30 is, I might do this, 3 times 10. Again, this is going to be prime. 10 is not prime, though. This is going to be 2 and 5 again. So 30 is equal to 2 times 3 times 5. Sometimes I like to make sure also that I've got all those numbers marked off, because sometimes you can have a lot of extra numbers. So I've got 2, 3, and 5 there. So now let's do this with another route, another way of doing it. So let's instead do 6 times 5, because 6 times 5 equals 30. 5 is prime. Now I'm going to break down 6, because that's a composite number, 3 and 2. Both those are prime. So again, 30 is going to be equal to 2 times 3 times 5. So both of them are the same, will give you the same prime factorization, which is this longer multiplication problem. It just is that the path doesn't matter provided you get the division correct. So here we're going to do a bigger one, 72. Now, 72 you might know is 9 times 8. You might not know that. But I do know for sure it's divisible by 2. That means I can divide 2 into it because it's an even numbered composite number. So if ever you get stuck, just go with 2s, 3s, and 5s and see if they divide into something to check it out. So here, if I wanted to break this down, this would be 2 times 36. That's prime. Again, 36, I might know another way of doing it, but I'm just still going to break it down as 2 times 18. Now this is going to be 2 times 9. And finally, 3 and 3. And that means that 72 prime factorized is going to be 2 times 2 times 2 times 3 times 3. Again, just making sure I got these 2, 2, 2, 3, 3. I got them all there. So that's the prime factorization. Whenever you prime factorize something, you want to have the lowest prime factor to the left and then move it on to the right. So your 2s are going to end up in front of your 3s are going to end up in front of your 5s, and so on.